How might you put a telescope in orbit that is greater than the rocket that is going to launch it? Is it even possible, considering that everything existing in space, or at least in our planetary group, is already there to the extent that we know? Everything in space is exceptionally old, so the chance of something new appearing there seems incredibly improbable. The reverse is true. The James Webb Space Telescope, JWST, by taking incredibly detailed photographs of the universe, has caused quite a sensation. Generally, the greatness of science is that it welcomes new data instead of dismissing it. Despite the warm reception to new data, some of what the telescope is observing is still bewildering and confusing. What have experts noted from the James Webb Space Telescope that has them perplexed? What mysteries about the dawn of humanity, as far as we're concerned, has the telescope opened up? Until this point, we should find out. Recently, NASA, the European Space Agency, and the Canadian Space Agency collaborated to give astronomers all over the planet a rare gift and an amazing opportunity to briefly explore the past at the creation of the universe and the edge of time itself. The James Webb Telescope, hailed as the main observatory of the next decade, stands as one of the most significant scientific achievements in recent memory. It opened this powerful window into creation, not as a philosophical speculation, enchanted time machine, or imaginative portrayal, but as a significant instrument. On December 25, 2021, this massive infrared telescope, more generally known as Webb, was set off, not entirely destined to capture photos of the dark and unravel the secrets of our mysterious universe. The state-of-the-art infrared detection equipment on Webb works on the unique perspective of the universe that Hubble has provided humanity, revealing the hidden universe to our eyes. From its vantage point in low Earth orbit, Hubble has captured numerous, previously unseen images of distant regions and pivotal moments of our universe, exploring the history and evolution of cosmic structures, stars, and clouds. It has described the characteristics of black holes, exoplanets, and the accelerated expansion of our universe. This groundbreaking work earned the Nobel Prize in Physics in 2011. Webb represents the next stage in our collective understanding of space, unveiling the universe's secrets and searching for life beyond Earth. Hubble's images have depicted modern cosmology, opening our eyes to what lies beyond and sparking our existential curiosity. As NASA puts it, if we want to see farther and deeper, Webb can peer back to the beginning of time, while Hubble can gaze up to approximately 500 million years after the Big Bang. How is this possible? The latest space telescope boasts several advantages over early models. Its size is the first remarkable aspect. JWST has a 6.5 m mirror comprised of 18 gold-plated hexagonal segments. This behemoth can gather light from objects many times faster than the 2.4 m primary mirror of the Hubble Space Telescope, as it can collect over 6 times as much light. However, the true game-changer is JWST's affinity for infrared light. The Space Telescope can detect frequencies between 0.6 to 28.5 micrometers, spanning the mid-infrared to the red end of the visible range. While most of Hubble's sensitivity focuses on visible light, its optics are tailored to capture radiation from 0.9 micrometers in the near-infrared to 2.5 micrometers in the near-infrared. Astronomers can see galaxies that formed less than a billion years after the Big Bang by using the infrared range. These distant objects emit clear and bright light. However, due to the expansion of the universe, this radiation is now emitted at longer infrared frequencies. One fantastic way of seeing these young systems near Earth is through infrared observation. This also applies to newly formed stars. Young suns are surrounded by dust, which scatters visible light, obscuring our view but allowing infrared energy to pass through. Infrared radiation is invisible to humans. The colors of images obtained by JWST differ from what the naked eye would see. To simulate how astronomers frequently map longer infrared frequencies to the red end of the visible spectrum and shorter frequencies toward the blue, this pattern is adjusted to highlight specific details. JWST serves as a versatile observatory, not just focusing on distant massive systems and star formation. Its robust infrared capabilities enable it to observe features in nearby planet groupings and areas that traditional telescopes can't discern. By focusing on cloud belts on gas and ice giant planets, monitoring cloud formations on Titan, studying Pluto's environment, and investigating quite a large number of smaller asteroids and transneptunian objects throughout the outer solar system, are just a few of its initial achievements. When NASA's Double Asteroid Redirection Test spacecraft collided with the space rock moonlet Dimorphos, JWST even got a brief look at the event. This allowed NASA to assess the object's ability to alter the course of potentially hazardous space rocks that could intersect Earth's path. Despite the efforts of planetary scientists to uncover the hidden secrets of our solar system, more than 5,000 known exoplanets in our astronomical systems remain unknown. The vast majority of this additional information lies beyond the limits of Earth-based telescopes, including Hubble. However, JWST has already begun to change what is happening. While not specifically designed for exoplanet discovery, JWST identified one around the red dwarf star LHS 47541 light-years from Earth. This planet's diameter is just 1% smaller than Earth's, but it orbits its sun in just 2 days and exhibits a temperature a few hundred degrees hotter than Earth. JWST's main strength lies in its ability to study exoplanet atmospheres by observing their transit regions. Astronomers can explore the chemical composition of these worlds. Most combinations significant to exoplanet experts are found in the infrared region of the spectrum. JWST's remarkable objective has allowed for the discovery of several compounds on exoplanets, including water, sulfur dioxide, carbon monoxide, sodium, potassium, and carbon dioxide. The gas and dust radiant incubators known as nebulae are where planets and their host stars form. However, despite their greatness, these clouds conceal the fundamental processes occurring within them from the rest of the view. JWST's infrared vision has begun to reveal these secret environments. For example, the Eagle Nebula, famous for its Pillars of Creation photograph taken by Hubble in 1995, was one of JWST's initial targets. While Hubble generally observed murky dust and chilly gas, JWST found several stars that had proactively emerged from their natal cocoons. These young stars, visible outside the shadowy cocoons of gas and dust, are distinguished by their diffraction spikes in images captured by reflecting telescopes like JWST. These exposures offer valuable insights into the formation and development of celestial bodies, revealing insight into the mysteries of our universe. But JWST has seen much more recently framed objects called protostars. These protostars are still in the process of accreting gas and dust from their surrounding environments. Occasionally, they emit material jets that pierce their dense surroundings, causing them to emit intense red glows. The two lower spikes are among the best examples of this phenomenon. These protostars are estimated to be a few 100,000 years old, as indicated by astronomers. Star formation occurs throughout the universe, and JWST researchers are eager to explore it. Numerous secrets beyond our world and within our local cluster are significant areas. The two main ones are the Large and Small Magellanic Clouds, both generally beyond the reach of traditional telescopes, including Hubble. However, JWST has already begun to shed light on what is happening. Colossal satellite. Enormous systems of the smooth way. It is crucial to handle these universes since they contain about a piece of how much metals conveyed by tremendous stars. As the smooth way, this current situation seems to be conditions that won when the universe was only 2 or 3 billion years old, and universes were making stars at a most outrageous rate. The vast frameworks outlined during this huge early evening time, including those we see presently, was shaped by the impacts during this period. The Tarantula Cloud, arranged in the enormous Magellanic Cloud, is the closest item in the Magellanic fogs to reflecting these fierce times. The Tarantula Cloud, the most critical star outlining zone in the speedy universe, makes stars at an infuriated rate. About 820,000 stars have been recorded by stargazers to date, and the enormous stores of hydrogen and helium the cloud holds should be sufficient for a large number more. The wonderful star bunch R136 near the focus of the cloud contains different stars, checking somewhere around 100 sun-powered masses. The JWST is beginning insights have revealed one-of-a-kind detail of the Tarantula Cloud. In the focal point of the cloud, a sizable air pocket has been gotten out by the exceptional radiation and grand breezes of the colossal stars in R136. No doubt, the densest neighbor in regions which presumably contain kid stars of their own can persevere through this assault. The tarantula cloud gives space specialists with a close-by perspective of the conditions they would insight as they further investigate the grandiose late morning view of adjoining characteristics. Every now and again, help scientists with seeing more distant ones even more clearly. Likewise, as star plan in the melanic fog reveals insight into near cycles in the far compasses of the universe, planets in our close-by planet bunch add to the examination of exoplanets. Moreover, research on barry-acting universes directly adds to how we could decipher nature beginning stages of the universe. JWST was built to focus on old frameworks shaped toward the beginning of the universe directly, and scientists have been getting a charge. At any rate, out of testing incapacity, abutting areas can routinely go about as analogies for more settled, more distant circumstances. A significant field image of the grandiose framework PAC-SMAC 723 in the Southern Star Gathering volumes was quite possibly of JW's most important image. Moreover, the first made available to the public, this transparency, which took 125 hours, rather than weeks for Hubble's different significant fields, gets astronomical frameworks comprehensively. These far-away, inestimable frameworks, even fainter and farther away than what Hubble could perceive, are perceptible in the SMAC as a 723. Bundle. The light we get from this pack is from around 4.6 billion years earlier. In any case, due to the bundle titanic mass going similarly a gravitational point of convergence, frameworks saw as further away, including those current inside a billion significant stretches of the colossal explosion, are recognizable. The humblest universes in the field, organized farthest away, don't seem to be the more made winding and bended frameworks closer to our planet. A basic disclosure made using the colossal world pack FIT 27144 in structure as a gravitational point of convergence is the impression of two universes, barely 450 million and 350 million years after the tremendous blast separately. These universes appear phenomenally amazing and conceivable, begun to structure hardly 100 million years after the immense blast. Scientists are dubious if these universes include different weak stars or then again a couple of exceptionally splendid people. 3 stars acknowledged to be the first stars in the universe made solely out of hydrogen and helium. Another new finding by the James Webb Telescope is the imaging of a gathering of infinite frameworks, so to speak 600 million years of age all along of the universe. While the real age may not be particularly fascinating, the circumstances incorporating this disclosure are moderate. By pointing telescopes towards the universe's beginning stages, we can observe events that occurred billions of years earlier when they light over the long haul gets in touch with us. These gigantic infinite frameworks only 600 million years or less from the earliest beginning point address attest to our progressing getting it of enormous framework improvement. Their speedy turn of events raises issues about the cycles involved and challenges long-held intelligent theories. These disclosures include the fundamental motivation driving shipping off the James Webb Telescope to stretch the boundaries of our knowledge and challenge recognized coherent bits of knowledge. What more Webb will find stays dark, yet it's certain to continue reshaping how we could decipher the universe through its careful discernments. Also, significant imaging skills. The James Webb Telescope is prepared to uncover more privileged insights of the universe and conceivably upset our enthusiasm for the universe's beginning ages and universe advancement processes.